Welcome back again, class. Thank you for joining me for our third day of 5-3. This is going to be a final installment of this section. Today we're moving to our fifth technique of how to solve these polynomial equations. And the cool thing is today I'm going to introduce you to how to use the calculator to solve these. So, the problem is, this method you will only ever find real solutions. You will never see complex solutions to the equations. However, we will talk in the following sections how to find the complex ones with the starting point of using a graphing calculator. So, I've set up kind of a system, a set of algorithm, so you can see exactly what I'm about to show you. So if you ever forget or get confused about the steps I'm taking, you can go back and look at this step-by-step process. Now, when we're looking for the zeros, the x-intercepts, again, graphically, we're looking for these 2 points right there. So that's what we are going to be looking for. So if you have a graphing calculator, please make sure that you take it out and follow along. So first thing I'm going to do, I need to graph the function. So I'm going to clear out the current function that I have in there and now type in x squared plus 2x minus 7. And I'm going to graph it. So that's what we're looking at. That is what I want to find the zeros of, the x-intercepts of. Now, it's going to be very similar to the process I taught you for the relative max and mins. So first, we're going to go under that calculate tab. And to get to calculate, remember we hit second, trace. But now, instead of going to minimum or maximum, this time I'm going to the zero function, okay? I wanted to calculate the zero for me. So I'm going to hit enter. And now it brings up the same cursor and is asking for the same thing. So from this point on, it is identical. Where I think the zeros are, I need to find the left bound, the right bound, and then it'll fully calculate it for me. So let's start with our left-hand one. So I'm going to start with this 0. And it wants me to highlight anywhere left of it. So there, I have gone left of my 0. Now it's asking for a right, or for me to go to the right of my 0. So there, I am now to the right of my 0. And again, when guess comes up, you don't have to do anything. Just hit enter one more time, and it'll calculate it for you. So notice down at the bottom, it says x equals negative 3.828427. That is our 0, okay? That's the x-intercept. So right now, please write down negative 3.83. You're going to have to know that, okay? So that's our first intercept. Now, we have another one, though, that right side. So I'm going to go back to calculate so I can do this process again. So go down to 0, and now this time, I need a left side bound of the other one. So I'm going to scroll over so I'm right there. That's to the left of the 0 that I'm looking for. Now it's asking me to move to the right of that 0. So I'm going to scoot right. There we go. And now again, when it says guess, all you have to do is hit enter one more time. And then you've got it. 1.8284271. And again, all I'm really expecting is you to be able to write down 2 decimal places for me, okay? So you can just call that 1.83, and that'll suffice. And so in this case, where there's 2 zeros, that's all you have to do. And if you look here, I did give those to you, so you'd automatically have them. Okay, but again, to find zeros using the calculator, that's really all you have to do. That's all there is to it. Now you do have to realize how many zeros you're looking for. So in this case, this cubic function, and again I can say it's cubic because it has that degree 3. For this one, I'm going to have to do this process 3 times. You have to do this process for every zero that you see. Okay? So let's go back to our calculator. And let's graph this one so we can find the zeros. So I'm going to clear out that function. X cubed minus 4x squared minus x plus 5 graph. I'm sorry, did I type something in wrong? Oh, put a 44. There we go. Much better. So here is our graph. So now let's go through and do this process again. So I'm going to calculate the 0. And I'm going to start from my leftmost 0 and work right. So here is a left bound of that 0. Now I'm going to scoot right. And there's to the right of that 0. And so it is telling me my 0 is at negative 1.09. So I'm going to go really quickly and I'm going to write that in. That this one is at x equals negative, oh, I'm sorry. I'm going to write that first 0, negative 1.090. Let's calculate our next one. So I have to go back into calculate. Oh, 0. Now let's do our middle 0. So here I'm to the left of it. Now it's asking for the right hand bound. So I move to the right of it. Hit enter. Hit enter one more time. Now it's telling me that 0 is at 1.16. So let's write that in. So this 0 is at 1.16. And now let's look at our final 0. So I'm going to go into calculate. Want it to calculate the 0 for me. All right. There's to the left of it. There's to the right of it. Hit enter one more time. 3.93. So that 0 is at 3.93. And there are the 3 x-intercepts that we were looking for. All right, so as you can see, using the calculator is pretty easy to get all of these zeros. You just have to know that technique. Now, I do want to take a moment and review with you. What do we know so far? We've done a lot of work with these polynomials. So let's go through one example and discuss everything we've talked about this chapter so far. So here's my polynomial. First thing, name it by degree. Well, I see it is a 3rd degree polynomial. So that's going to mean it is cubic. I see 1, 2, 3 terms. If it has 3 terms, that means it is a trinomial. All right, and we also know how to find the zeros graphically and by factoring. Now, I'm going to leave the graphically up to you because I just showed you how to do that twice. However, just to remind you how to do this the factoring way. So we have x cubed minus x squared minus 6x equals 0 if we're searching for the x-intercepts. Now notice, there is an x in every term. So the method of factoring that I think is appropriate here is to pull an x out of everything. When I pull an x out of everything, the x cubed will come down to be an x squared. The x squared will come down to just be an x, and the 6x will lose its x. So now notice I have a quadratic left in my parenthesis. So 3-term quadratic. Let's see if this factors. All right, if it doesn't factor, then we'll have to use the quadratic formula. But just let's see if it does. So that x squared comes from x and x. Two things that multiply to -6 and add to -1. Well, I believe those two would multiply to -6 and add to -1. So, now remember, using the factoring method, remember this is going to give us an x-intercept at 0. This will give us 1 at 3. And that one will give us 1 at -2. So don't forget, even though now you know how to use the calculator, don't forget that factoring is important. You will have to know how to do that when it comes to searching for every zero or every root. We know how to describe the end behavior of a polynomial. So looking here, to the left is going down, which is going to mean it's going down to -infinity, and to the right is going up, which is going to be going to +infinity. So don't forget end behavior. What is it doing to the left? What is it doing to the right? So we would call this a down-up end behavior. We know how to identify maximums and minimums. So looking at that now, we will need the calculator to do this. So I'm going to pull my calculator back up. Maximums and minimums. Well, first I need to type in this function. So x cubed minus x squared minus 6x. Now remember, relative max and mins. So here I'm going to do that relative max first. So going to calculate, and I go to maximum. And just like what we've been doing today is asking me to start at the left of the relative maximum, then identify something to the right of the relative maximum, hit enter one more time. It's telling me is that 1.12. So, and I'm sorry, I forgot to look at the y value for that, but the relative max 1.12 and 4.06. So that's the point of the relative maximum. So let's look for the point of the relative minimum. So I'm going to go back into calculate again. This time go to minimum. Scroll over. So that's to the left of my minimum. Now I need something to the right of my minimum. Hit enter. So 1.79 and -8.21. So that's how we calculate relative max and mins. All right, and then there was one more thing that we've talked about. intervals of increase and intervals of decrease. So remember, think of it like riding a roller coaster, okay? So here, my roller coaster is going up. We're riding up the curve. So first let's identify. Here, that maximum was at an x of 1.12. Oh, I'm sorry, that would have been a negative. And then my minimum was at 1.79. We're looking at the x values. So that first rise is when x is less than negative 1.12. And then look at what happens. Then it starts falling, starts going downward. Now, where is it going downward? Well, it's decreasing in between those two x values. So in between my max and min, it is decreasing. And then it turns around and it starts going back up again. So then once it hits that 1.79, everywhere greater than that 1.79, it is increasing again, going up. All right, so I thank you so much for joining me today for this video. So please make sure you have all this written down, especially this review, because this is an accumulation of everything we've talked about so far, piecing it together and looking for the big picture. So please make sure you have all that written down and then come back to class ready to do our practice work.